Yep, that's me. I can now prototype anywhere I want because I built this Cyberdeck. It's made specially for makers and it has access to the GPIO pins of the Raspberry Pi inside, or it can program a microcontroller directly. It has an USB port which can be expanded using a hub, and it can also be directly charged using a Type C cable. Come build this with me. It's made of these 3D printed parts. And in this build, my goal was to use readily available parts as much as possible and not rely on custom PCBs or any specialized parts. Looks like the 3D model I used to design the case was a bit off or a different from the actual cable that I have. I think I'll have to strip off some plastic from the sides and from the top. I'm using a generic 5-inch resistive touch display and this adapter that came along with this display. If you don't have a 3D printer and want to print this project, you can get them printed from JLC 3DP. If you haven't heard of them, JLC 3DP delivers industrial grade 3D printing that bridges prototyping and production, helping makers like us bring concepts to reality with speed, precision, and cost efficiency. I can upload the project files straight to their site and get an instant quote in seconds. And the whole order should be ready in about 48 hours. What actually surprised me is the material range. They've got over 20 materials to choose from, everything from standard resins all the way up to engineering grade nylons and even metals. Parts start at just 30 cents. You can 3D print for just $0.3 and stack that with up to $123 in coupons from JLC 3DP, and it is a steal. Link is down below if you want to try it on your own project. I'll be using this power bank to power the Cyberdeck, but simply plugging in the Raspberry Pi to the power bank does not work because we will be left without a way to turn off the Cyberdeck. So I'm adding a switch in between the power lines. There's a small window in the front panel so I can see the battery capacity of the power bank. So I have to align the power bank to the window. I feel like there is too much stress on the USB wire here. We also have an option of using a wired micro USB adapter. Let me quickly turn it on before sealing everything. I think it is having trouble powering the Pi and the display both together. I think the problem are the jumper wires that we are using to connect the power supply. So I cut a micro USB cable and soldered that to the switch so we can power the Raspberry Pi directly using micro USB. And now everything works as it should. I'm not including a keyboard or a mouse in this build because my primary goal was to keep making while I am on the move. And a breadboard and access to GPIO pins was more important to me because I can just carry a wireless keyboard, plug it in, and use that. If you liked this project, we make open source projects every week. Subscribe to support us and keep all the projects open source. And until the next one, keep making.